Alright, hello again, and welcome back to the skeletal lecture. We are now going into the subject of endochondral ossification. So, in this case, we're going to be starting off with a cartilage model that was grown beforehand. Now, to make cartilage, you need cells called chondroblasts. Chondroblasts were derived from osteogenic cells. So once again, we're starting from the same sort of origin tissue that you went through, that you needed in order to create flat bones through intramembranous ossification. But now endochondral ossification is going to be the main method by which we're going to create most of the long bones of the body. Right? So things like the radius and the ulna, things like the humerus, and let's say femur, tibia, fibula, even the finger bones and toe bones, and of course parts of other bones, like one half of your clavicle, particularly the lateral half, is going to be made through endochondral ossification, but the medial half is made through intramembranous ossification. Still, the endochondral part, the chondro means cartilage. So you have to start off with a cartilage model, and in this case we're talking about this right here, right? A cartilage model that might be found, say, in the hand of a fetus. The osteogenic cells already turned to chondroblasts. The chondroblasts then grew cartilage tissue. That cartilage tissue then got larger and larger as more of it was deposited. And a part of that cartilage growth is that there's still always going to be a layer of osteogenic cells on its surfaces. And that cartilage will be surrounded by a sheath of fibrous connective tissue that is called the perichondrium, which is very similar to periosteum, except in this case it's around cartilage rather than bone. Right? So let's see, try this, right. Eliminate that. So I'll use blue this time as indicating cartilage tissue. I will use brown to indicate the fibrous connective tissue of perichondrium that is wrapped around it. Okay. And this perichondrium will have, in orange underneath it, osteogenic cells in a layer much more dense than what I'm drawing right here, but still loads and loads of osteogenic cells sitting under your cartilage waiting for instructions to become something else, but in the meantime multiplying, multiplying, multiplying. Right? So the cartilage itself is going to keep on growing. Some of these osteogenic cells are going to become chondroblasts, which will then create cartilage tissue, and so eventually your cartilage model will continue to enlarge. So at some point you're going to need, say, a larger cartilage model like this one. Right, there we go. But between here and here, a few things are going to change. First of all, this cartilage model is going to have to eventually be hollowed out from the center and remove the cartilage that is there in order to fill it with bone. But the thing is, before that space gets removed, we need to fortify the outside. You see, if you make a big hole in the middle of your cartilage model, then that means that you're going to weaken it from the interior, and we don't want to do that. We want to make sure that it's still structurally sound so it can handle whatever strain is being put on it by the developing child in the womb. And of course, once they get out, there's even more strain going to be put on it because it's going to be more, afflicted by gravity. So to make sure that this stuff is fortified, one of the first changes that's going to happen is we're actually going to be growing bone around the exterior of the cartilage model in what's called a bony collar. Right? Now, to make that bony collar, it's a pretty simple procedure. In fact, you saw it in intramembranous ossification. Some of these osteogenic cells here, right, are going to transform into osteoblasts. Osteoblasts will lay down osteoid tissue, which is, a collagenous tissue, but it's going to be laid down here on the surface of the cartilage model. Okay. So that cartilage model now has a thin layer of osteoid tissue populated with osteoblasts that are then underneath this perichondrium fibrous connective tissue. And let's not forget, the osteogenic cells are still there multiplying. Right? But the osteoid tissue then will be calcified. And when it calcifies, it's going to be turning into spongy bone. In quick order, that spongy bone then has its holes filled in and turned to compact bone. And it's not just going to be in this area right here, but covering the entire surface of your cartilage model. So we end up with a bony collar that is wrapped all around your cartilage model, kind of like a hot dog around a bun, or sorry, a bun around a hot dog. Not a hot dog around the bun, this is the way I am. Or maybe for a corn dog, right? Because there you go, you have a soft, chewy center, in this case cartilage, surrounded by a hard shell, right, of compact bone. And now, this cartilage model is ready to have the center carved out by removing the cartilage in preparation for replacing that with bone. So the bony collar that is grown through intermembranous ossification has to be put down first before the rest of endochondral ossification can occur. Otherwise, it's very possible the model could break. Okay? So here's your next step. Now that you got the bony collar on the outside of your cartilage model, right, and that bony collar has around it a periosteum now. It's the same material as perichondrium, dense, irregular, fibrous connective tissue. In fact, it's the exact same tissue, it's just that now there's bone underneath it rather than immediately cartilage. And so that's why it goes to periosteum rather than perichondrium. But inside, the center tissue here in the diaphysis of your long bone model, it's populated with chondrocytes. Those chondrocytes are just normal chondrocytes helping to maintain the tissue, but now they're going to be in the location where bone will first form, and so that location is called your primary ossification center. Eventually there will be secondary ossification centers, but they're going to be up here in the epiphyses, here and here, right, as opposed to here in the diaphysis, which is where it's going to be starting. Right. Oops, raised too much. Alright, so we follow the action of the chondrocytes here in the middle. First thing they're going to do is they're going to start to enlarge in size. Now, they're trapped inside of this hard rubbery matrix, so in order for them to enlarge, they actually have to consume the walls of the matrix that they themselves put down when this cartilage is being made. Right? So they essentially eating the walls away, and thus the chambers that they live in are going to keep getting larger and larger. Right? Those chambers, called lacuna, continue to enlarge until they start to abut the chambers of the other cells that were nearby. So we end up with this large space, large-ish, that is filling the center of the diaphysis of your cartilage model, and it's populated by enlarged, hypertrophied chondrocytes. Okay? So now we've got the space prepared for bone growth, but it's occupied by very, very large and fattened chondrocyte cells. So the trick is we're going to have to get rid of them before the new occupants can move in, the osteogenic cells. So what happens next is you allow those cells to die, right, by telling them to undergo their own cell suicide programming, right, a process called apoptosis. But with removal of those cells, you now have the space filled with just kind of a cellular sludge, which is actually pretty nutritional stuff. It's got amino acids, it's got carbohydrates, it's got all the pieces of the cells that used to live there, now just decomposed down to their smallest size. And so, without those cells present, but their remains sticking behind, we've now got the perfect place for new bone to grow. But before we can do that, we need to get osteogenic cells into this space. And the osteogenic cells are all out here, underneath the perichondrium, outside of the bony collar. Right? So how do we get those osteogenic cells into that primary ossification center? Well, they're going to be led in thanks to a blood vessel. Blood vessels always grow to wherever there's more tissue being made. It's just part of their natural growth patterns. If there's new cell growth happening, then you should have a blood vessel trying to move into that direction. Well, that's what's going to happen here as well. Blood vessels are going to be growing, a process called angiogenesis, towards the primary ossification center. But to get there, they are going to have to go through this bony collar that was wrapped around the cartilage model, and for that matter, they have to go through the periosteum on the outside. This will be thanks to osteoclast cells. osteoclast cells, I'll draw them here in green, they are going to be picked up from the surface of the bony regions, and they will help to burrow the way in, allowing the blood vessel to go along with it. Okay? So the osteoclasts help to make the tunnel, the blood vessel grows through the tunnel, and it also goes through the periosteum on the outside. And because it went through the periosteum, it brought with it some osteogenic cells. And now osteogenic cells, here in orange, start to populate the primary ossification center, and they will set themselves up all around the walls of that ossification center. Then, some of them are going to turn to osteoblasts. The osteoblasts will lay down osteoid tissue, and once you've got osteoid tissue, you can then calcify it, and it becomes spongy bone. So I'll just do a little bit of erasing there. So you end up with spongy bone filling your primary ossification center, and of course being supplied by blood that has been supplied by the blood vessels that grew into this region. Okay? And there we go, we've now finally got bone formed on the inside of a cartilage model. Then basically you just repeat the entire process. The cartilage cells that are nearby the primary ossification center, they are now going to go through their own hypertrophy. They'll get larger. Their walls will start to join with one another, and that'll be happening above, below, and to the sides. Right. Cartilage cells will undergo hypertrophy first, and then once their walls are all joined together, those cells will be told to die. And so we remove the cartilage cells. There's already a blood vessel in here, there's already osteogenic cells in here, and so those osteogenic cells will now move in to populate the surfaces of your enlarged ossification center. Right? Those will then become osteoblasts. The osteoblasts will lay down osteoid tissue. That osteoid tissue will then eventually calcify. The calcification leads to the creation of more spongy bone. And so we continue to fill the interior of this space with spongy bone. Okay. And now just keep on going. The cartilage will eventually be replaced in this direction, and this direction, and of course it'll be replaced towards the sides too. But the sides are thinner. And so eventually you'll end up with the cartilage on the walls here and here being replaced far sooner than the cartilage that's above and below in the epiphyseal regions. Oh, and let's not forget, the cartilage is also probably growing, not probably, it is growing as well. There'll be some massive cartilage that'll be added to the walls, growing to the sides, but there'll be more of it being added, in the directions of the epiphyses. So your cartilage model continues to get longer. The reason that these pictures, by the way, are so wobbly is because I'm using a trackball, and one of these days I hope to get a stylus so I actually, show my drawing skills a little bit better. But the cartilage model continues to enlarge, right? It will still have its osteogenic cells peppering its surface. Oh, but don't want to forget that you've got the bony collar out here. The bony collar out here. Bony collar out here, surrounded by the periosteum. Right. There we go. And the population of osteogenic cells just underneath that periosteum, but on the surface of the bony collar. Good. In the middle, you have now grown an awful lot of spongy bone, so much spongy bone that it may even have completely filled the interior side to side, which means that spongy bone finally has joined with the bony collar around the edges. And the cartilage has been completely removed here in the center diaphysis shaft section. Okay. But that's not the way things usually end up. In a long bone, the center is filled with a hollow medullary cavity. And so the way we're going to get that cavity is by removing the spongy bone that was grown beforehand. And the cells that are responsible for that are your bone destroyers, the osteoclasts. The osteoclasts, they'd already been brought inside during the time when the blood vessel was moving in, and because the osteoclasts burrowed their way in there to allow the blood vessel to grow to that space. So there are already osteoclasts on the inside, and those osteoclasts are now going to be removing a lot of this extra spongy bone, leaving behind the hollow medullary cavity. It doesn't get rid of all the spongy bone, it still leaves some spongy bone. They'll be clinging to the walls of the bony collar, and that way the bony collar is actually going to get thicker. Some of the holes of the spongy bone will be filled in, so let's use this one. There we go. And now we have a lot of spongy bone forming the diaphysis, like so, with a hollow medullary cavity and tips that are still made up of cartilage out here and here. Now, your osteogenic cells, they are still persisting on the surfaces, here, and so forth. Okay. But there are also osteogenic cells here now, on the inside of your medullary cavity. And here's where the next step to endochondral ossification occurs, in the epiphyses. The epiphyses are where we are now going to see the secondary ossifications occur in the middle of those epiphyses. The chondrocytes will first go through their hypertrophy again, and they will enlarge, they will consume the walls of matrix that they made, and eventually create a single shared space with lots of big fat chondrocytes inhabiting them. Right? Then those chondrocytes will be told to die, right? Leaving behind your secondary ossification center spaces filled with cellular sludge. Then blood vessels, as expected, will now grow into those areas, assisted by osteoclasts dissolving their way in, right? And when the blood vessels pass through these surfaces, they will bring with them osteogenic cells. Those osteogenic cells that move into this area will now populate that internal space. They will transform into osteoblasts. Osteoblasts will then form osteoid tissue. Osteoid tissue, oops, wrong color. Osteoid tissue in light blue will then eventually calcify in these areas and become what kind of bone? More spongy bone. Okay. And now continue the process. Wherever there's still cartilage, you will have more chondrocyte hypertrophy first, followed by chondrocyte apoptosis, where they die. Then you have the invasion of osteogenic cells into those spaces, and then when the osteogenic cells are there, they will turn to osteoblasts. Osteoblasts will lay down osteoid tissue. Osteoid tissue will calcify and form spongy bone, and as you need to, fill in the holes to form compact bone. And as you need to, in some places, you may need to remove spongy bone, and you'll do that with osteoclasts. So, when you finally get to nearly the end of your bone growth, you will have something. Let's draw a whole new picture here. You'll have something that looks like this. Let's see. You'll have a center bone shaft, the diaphysis, which will have inside compact bone on the walls, and then there will also be a medullary cavity on the inside that will be populated with osteogenic cells, Okay, so there's always a chance to make new bone from the interior as well, but most of the space is going to be filled with bone marrow. And then at the epiphyses is where we're going to have more compact bone on the surfaces, here and here, right? But the interior, for the most part, is just filled with lots and lots of spongy bone. Yeah, definitely need something other than this trackball. Alright, let's see, draw that there. Alright, so compact bone on the outside. Wrong color, but whatever. Compact bone on the outside, spongy bone on the interior, and the only cartilage that remains now is this stuff right here that lies between the epiphysis and the diaphysis. And that region right there is called the epiphyseal growth plate. The growth plate is where more cartilage will continue to be added from the interior. So the cartilage will go this way, and thus push the bony epiphyses away from the diaphysis. Right? And so that growth that happens at the epiphyseal plate is going to be the subject of the next lecture video, which is going to be on the action of the metaphyses. So we'll call this here, and I'll talk to you later. Bye now.